This is a mini lesson on section 2.7, absolute value equations and inequalities. The key thing to remember about an absolute value equation and inequality is that an absolute value refers to distance from 0 on a number line. Now if you think about distance and the value of distance is always positive. So let's look at these two absolute value equations. The absolute value of 5 means that we are looking for a number in the place of x here that's going to give us a distance of 5. So let's look here at the number line. Now remember, absolute value is distance from 0 on a number line. So if we take the number 5 and the number -5, notice that both have the same distance of 5 units. So the distance from 0 to 5 is 1, 2, 3, 4, 5. And the distance to -5 is also 1, 2, 3, 4, 5. You can refer to this as units. So we have two answers that satisfy this particular equation here at the top, because both 5 and -5 give us a distance of 5 units. We're going to use this to help us to solve our equations. Okay, so what we're going to do is look at this particular slide just for absolute value equations. There are 3 steps here that we want to make sure that we follow. The first step is to make sure that the absolute value is on one side alone. This is also referred to as standard form. After we determine standard form, if needed, then we're going to check to make sure we have a positive number. If the number is not positive, that's going to be a special case, and I'll talk about that in a moment. After determining that positive number, then we're going to set 2 equations. Okay, one equation with the positive number and the other equation with the negative number. And these numbers are the 2 numbers that's going to give us that particular distance it's equal to. So let's look at this example. 2x plus 1 equal to 7. To solve this equation, this absolute value equation, what we're doing is we are looking for a value here at x that when we substitute is going to give us this distance of 7. This equation is in standard form. It's equal to a positive number, so it's equal to a distance of 7. So we're going to set up 2 equations. One equation we will keep the number because one number that will give us a distance of 7 is 7. The other equation will contain 2x minus 1 equal to the negative or the opposite of 7, which is -7. From here we're going to solve. We're going to subtract 1. If you think about the steps to solving equations, remember ESRDC from the previous lesson in 2.1. Here we're going to rearrange, bring our 2x down. 7 minus 1 gives us 6. Divide by 2. We get a value x equal to 3. We're going to rearrange the second equation. We're going to get 2x equal to -6. And at this point we will divide by 2. And we end up with -3 in this particular case. Oops, I'm sorry, I copied the problem wrong. It should be 2x plus 1, so we're going to subtract 1 here. instead of adding 1, so that's going to change and give us a negative 8. And then negative 8 divided by 2, okay, divided by 2 gives us a value of negative 4. So what that means is our two solutions here is a solution set negative 4, 3. Okay, as our final answers. So that means that when we substitute negative 4 in the place of x, that's going to give us an absolute value of a negative 7. The absolute value of a negative 7 is a positive 7. And when we substitute 3 in the place of x here, that's going to give us 6 plus 1, which is 7, and the absolute value of 7 is 7, because remember, those two numbers have a distance of 7. We'll look at one more example here. This particular absolute value is not in standard form, so we're going to put in standard form. To do that, we want the absolute value to be by itself, so we are going to move the positive 5 over to the right by subtracting, which gives us an absolute value of 3x minus 4 equal to 7. So we're in this equation here, we're also looking for a value here in the place of x, two numbers that's going to substitute in to give us a distance of 7. This number is positive. We can set up our two equations. 3x minus 4 equals 7, 3x minus 4 equal to negative 7. We are going to rearrange again to get 3x equal to 11. Divide by 3, x gives us 11 over 3. Here we're going to add 4 again. We get 3x equal to a negative 3. Divide by 3, we get x equal to negative 1. So our two solutions here will be negative 1 and 11. Be sure when you're placing these two numbers into your solution set that the smaller number comes first and then your larger number second. The last case here, special case, we're going to work this exactly like we have. We're going to set up two equations, but this particular equation, I won't work the whole thing out, but I'll just set it up so you can see. We're going to keep it like it is here at the beginning, and then we're going to set up our second equation by doing the opposite. So that's going to give us a negative here in the front plus 7. What this does in the second equation is it just changes the sign of both terms, because we will end up distributing that negative. At this point, use your steps to solving an equation to solve for x. This example is in the notes on Blackboard if you want to see what the two answers are to this one. And the last special cases of absolute value. In this particular example here, if you notice, this is in standard form, but notice that you have a negative 5 right here. Remember, that number refers to distance. And remember, distance can't be negative. So in this example, we're going to get no solution. And for this second example over here, so any number back at this previous example that has equal to a negative is always going to be no solution. And for this particular example, because the distance is 0, we're only going to have one solution. So you just solve that particular equation.